slide through how to get through maybe your software engineering career, maybe what you should do to get into machine learning, and other ways or other tips you can use to succeed, okay? So I will start by introducing. I have a pretty unique name, right? My name is John Pangas, and I have worked with Mozilla Firefox. You can see the fox around there that's burning. I got to Mozilla through the Outreach program. I think most of you know Outreach. Do you? Yes. Outreach is a paid internship where I think they pay you $7,000 for 3 months, right? And it's a very rigorous process. I'm sure you've heard of most of the people trying to get in, trying and failing, and most of you, I'm sure, would want to try and at least have a chance, right? So we'll touch on that later in our presentation. Then right now, actually, I am developing machine learning tools for software engineering with the University of Calgary and working with Mozilla Firefox to incorporate them into their systems. Okay, I graduated as a software engineer from Zhejiang University of Technology in China, and I've been developing in Python since 2019. So I've got some pretty good ground on it, and I appreciate it as my first language, and I hope one day it could be one for all of you, okay? So that's a quick look at my introduction. So our overview of today, I want to see what is the impact of Python and ML in software engineering? How is Python and machine learning helping us as software engineers or in the whole software engineering chain? So we're going to look at how machine learning is used in each software engineering activity. And we're also going to try and I'll run through some case studies, one of the tools we're developing at Mozilla Firefox. And then also we will try and see one of the famous open source libraries, which is also part of an outreach project that maybe even you can contribute to. It's open source, okay? Then obviously I will share some of the resources for those who want to break through into machine learning. And I will also give you an example of someone's, should I say unlucky but lucky career path, where someone went from, I think she was studying medicine, then she went on to have a scholarship in software engineering. We'll see that finally, okay? Allow me to continue from here. I'll start with showing you the results of a populatory survey. What programming language do most data scientists use? So this was a survey done by Cargo, and it had 18,000 respondents. And of course, most of the data scientists definitely said that Python is their #1 programming language. We can all agree with that, right? Yes, and 83% of them agreed that they use Python in their day for building any machine learning tools. And to see us talk about Python and PyCon, you'd have to touch on machine learning. Now next, what is the direct impact of Python in machine learning? How has Python actually changed what machine learning has become right now? We're not yet touching on software engineering, but we're just going to talk about generally Python in machine learning for any application, building models to detect cats and dogs or to detect faces or for Face ID and stuff like that. So we look at it as what happened before machine learning met, or before Python met machine learning, right? People those days used to develop with C++ and Java. And this required extremely verbose code, which could even implement the simplest ML algorithm. You could imagine like linear regression. Writing linear regression in C++ and Java was extremely verbose. By verbose, I mean, you look at the number of lines of code you have to do to implement a simple solution. We can all agree that Java and C++ compared to Python is almost a no-brainer, right? Yes, then we also had, by those days, there were very little tools and libraries you could use, especially right now with the way Python has influenced the industry. Those days, everyone had to write custom code, or even the most simplest tasks like data processing. Then we look at, back in the day, if you wanted to develop a machine learning solution with C++ and Java, there was so much you had to learn. So there was a steep learning curve. It was very hard for beginners to get into machine learning. And there were limited resources, because of C++ and Java were mainly dedicated to desktop applications and kernel developments. This meant only highly skilled developers could explore the field of machine learning back then. But then came the big guy, Python, right? So with Python, everything changed. Python introduced key machine learning libraries, right? With that, it led to the rise of scikit-learn, TensorFlow, PyTorch. This one simplified the most complex tasks, and it made it easy for developers to build and train their ML models. Then, obviously, this also led to widespread adoption. Python's accessibility, easy to learn syntax, and the strong community made developers at all levels to explore and adopt ML. Okay? We can agree if something is easy to understand, it will be easy to learn and easier to what? To develop, right? Python's flexibility also made it easy for people to expand it in multiple industries. So ML didn't just become maybe for like internal companies. People now decided to bring it out. Let's use it on computers. Let's use it in software engineering. Let's use it in image classification, computer vision. And part of the reason we can also attribute it to the libraries. OpenCV, I'm sure most of us have touched on OpenCV, right? OpenCV is the backbone of so many computer vision libraries, computer vision tools that we use nowadays. So we can agree that Python contributed to the rise of machine learning and the rise of industries. And the one where I'm going to talk about today is my dear software engineering, okay? So this is the pathway of our talk today. We are currently in the middle. And I will start on machine learning for software engineering, okay? So Python right now, as we speak, is changing the field that I'm so passionate about, and that's software engineering. There's even a dedicated conference for software engineering. I think it's called ICSE, International Conference for Software Engineers. Here, I think ICSE last year was in Lisbon, and most of the people were talking about how machine learning is revolutionizing software engineering. People talked about applying ChatGPT. People talked about having automated tests, and even one, I think it was led to the, have any of you heard about Devin? You've heard about Devin, right? For those who may not know, Devin is an AI programmer. Devin can almost replace some of us in this room. I don't know if we're happy with that, right? We are not. So it's, we are trying not to be like Devin. We are trying otherwise to develop ways ML can supplement us in our work, okay? Let's go and see. So machine learning obviously is, we call it developing. In summary, for those who don't know, in machine learning, we derive models from data. That would be the easiest way to say it. And we are looking at how we can use such models in software engineering. We are seeing what kind of models can we use to help us as software engineers in all our processes. So one, in what way can we apply machine learning? That means, can we apply it while testing? Can we apply it while developing? Can we apply it while integrating? Or can we apply it while getting requirements, okay? I'm going to, so this would be the most important slide in our talk. Software engineering can be broken down into a series of activities. The first one, we call it software requirements. You know that's the first part. You need to know what you want to develop, right? So you usually want to understand the requirements. And with machine learning, we can find out what kind of specific requirements maybe a customer is trying to get. So even through user stories, we can ensure with machine learning that nothing is missed, okay? In software design, we can find the design pattern in large code bases. I'll give an example of Python, the Python code base. With machine learning, we are seeing people find design patterns, and this is helping developers adopt already proven solutions. In software construction, we had a workshop here of GitHub Copilot. You saw you can use GitHub Copilot to supplement your development processes. In software testing, which I will demo today, we have seen how machine learning can automate test case generation. So imagine you develop your code and you want machine learning to generate the tests for you. Maintenance, we can also detect bugs, which is done with us at Mozilla also. We have a platform that I will show later, how we use to detect and tag bugs. And software configuration, we can also see that machine learning supports learning new strategies. You know, software engineering, as we understand it here in Uganda, has not really matured, okay? In other places, it's extremely intense. We have large companies that have millions of software developers, and this whole chain from software requirements to software maintenance has a series of teams and developers. So even developing the simplest model can help save them a whole amount of resources. And for me, I want us to understand today how can we use Python if you're a developer yourself and you've maybe been placed into a software engineering team. What Python tools can you use to influence your workflow, okay? This is a given scenario. One, I have a customer who has given me a software to develop, and I want to know how can I implement machine learning in it. There are two Python libraries, NLTK and Spacey, which can be used to extract specifications from documents. That's one. We can also use the famous scikit-learn and PyTorch to classify maybe patterns in code, which is in design. We can also use, now to construct code or to generate some code, is CodeBat. CodeBat works almost similarly to GitHub Copilot. Use CodeBat to generate code and any other related tasks. For software testing, I will show you today with my practical how large language models like ChatGPT can be used with LangChain to generate meaningful tests. This one is actually practical, and we actually use it in our day-to-day operations at Mozilla. So for software maintenance, you can also build predictive maintenance models with TensorFlow or Keras. And also finally, for software configuration, you can implement reinforcement learning using Python libraries like Stable Baseline, and this will help you learn the optimal configuration settings. This is an example of what a complete machine learning engineer who's applying it within software engineering would use. It's just a tip of the iceberg, and any other solutions can be implemented. The trick is, for most of us as developers right now, we're living in the age of AI. Finding a way to supplement your workflow is what's going to set you apart from other developers. Right now, I believe it's about working smart and not really about working too hard, okay? As long as you get the job done. So, I want us to now go through some case studies and applications. I want us to check how are people developing machine learning tools and how are they using them in what? Software engineering. Let me just cross over here to my browser. I will start with Bugzilla. I don't know if most of you can see it. So Bugzilla is Mozilla's bug tracking platform. If you have any bug that is on any of Mozilla's products, that's Thunderbird, Firefox, Mail, all those bugs are reported at Bugzilla. So there are millions of bugs that get reported every week, and it's so impossible for everyone to say maybe this bug is related to the core development or this bug is related to tabs. So what we do, we build machine learning models through the bug open source platform to automatically tag bugs, okay? One would be, what is the product this bug belongs to? What component does it belong to? What person should we assign it to? And 4 is what category. Maybe it's a spam bug. Some people like to just throw their bugs there and their links, okay? So I'll give you an example. We are going to check through the most common one that we can relate is spam bug. So this is an example of an invalid bug. In no way is this related to Firefox products, right? Someone just came up and said, click WhatsApp app to open. So what we did is we have a spam bug model running in the background whose code we are going to check. Our main goal with machine learning here is we do not want to waste developers' time. A developer should not come and see an invalid bug and opens it. It's totally pointless because he has millions of other things to do. So we can first, this is the bug project that I was telling you about. This is the open source project. This is actually part of an outreach project. It was built by a Google Summer of Code intern. And he's the one who you can see there, Marco Castello. He was a Google Summer of Code intern who built this, and Mozilla appreciated him and retained him. So he built bug, as I told you, to automatically tag the bugs on what? Bugzilla. So here is where we host most of the models. We have models, I could scroll down. We have models to issue and assign it to the bug, models to know what kind of bug it is, models to know which component it belongs to, models to detect defects, and models to find out if it's a spam bug, okay? So ideally, this is the most important part of the spam bug model. Here we use just simple clean Python. You don't even need to see so much machine learning jargon, right? The most impressive part about this is how do we find out one bug is spam or one bug is not. In machine learning, we call these features. We're trying to find out what features make a bug spam and what features make a bug legitimate, right? The first one I think you can appreciate is if we have the name that at Mozilla in the email of the creator of the bug, right? We generally know this is a Mozilla employee, and this one cannot file a what? A spam bug, right? Then next we go and we check if we move the bug from the invalid bugs product, that definitely means valid bug. And if a bug was fixed, that definitely means it's also a valid bug. Then, if a bug has already been placed in the invalid products, that's when we know it's a spam bug. So this first process here is usually done by a human. We can get maybe a few people to come and automatically look at a bug and tell us, does this look invalid? If yes, we train our models with the information they've given us. And that's what helps us classify some of the bugs as what? Invalid. So you see, every single time a bug is reported, we run this bug through the machine learning models. And the machine learning models, through an agent, a bot called bugbot, tries to tell us what kind of bug it is. So you see what bugbot here is saying? The bugbot thinks this bug is invalid. So if you think the bot is wrong, the developer should reopen the bug and move it. So we can see the series of things the bugbot did. Bugbot moved the bug from Firefox to invalid bugs. This is all done by machine learning and some impressive, clever people at Mozilla who built a wonderful bot. So I would urge you to explore Bugbug and Bugbot in your free time. It's an open source project that actively is looking for people to contribute to. And once again, I said it's linked to Outreachy, which would be good for your prospects in case you want to join Outreachy. And another one that I would love to present is the tool I had told you that generates test cases. This one is one where I've built myself with the help of the other friends at Mozilla. What we really want to do is when we're releasing new Firefox features, we want to automatically generate test cases that the QA team has missed, okay? So supposingly we say we are developing a new feature called tabs, the ability to open a new tab, right? So there are a series of test cases that the QA team will develop, but we want to find out what has the QA team missed. So once again, I told you, machine learning to supplement the development process of software engineering. So I'll just give you a quick demo. Here we have, okay, wait. Let me just refresh that. So I'll sign in with my Hugging Face. Internal server error. Let me, hold on. Anyway, so here when we are developing these test cases, we give the QA team a link to our tool. So what does the QA team come? The QA team comes with their definition of a test plan. So test plans are usually used in modern software engineering to guide teams on how to test certain new tools. So in our tool, we want someone to come and tell us, well, what feature are you trying to create tests for? Let's call this the tabs feature, right? How do you describe the tabs feature? Tabs allows users to open and manage multiple web pages. So we can just copy and paste this into our tool. What's the test scope? How much do you want to test on this new feature? We say we want to test the functionality to make sure tabs can open, close, and restore. We want to test how it can be used. We want to test performance. We want to test cross-platform compatibility. And we also want to test for security. So as a QA engineer, I'll come and copy and paste this directly into our test scope. Now remember, it's machine learning to supplement software engineering. So I have my already determined QA test cases, but I want to find out those that I have missed. So I come and copy the ones that we have already developed together as a team, and I paste them directly here. Then the QA manager will come and click generate. So what does generate do in the background? Generate runs all the information we have given it into GPT-4. GPT-4 is the large language model that powers ChatGPT, and we use a technique called few-shot prompting, which is you give the model a few examples of what you want it to generate, so that it matches a bit of what we are trying to find. So we can see here from generated test cases that our model, GPT-4, has given us a list of 25 test cases. Down when we scroll, we will find, hold on a bit. When we scroll down here, we also developed a way to find out what has ChatGPT generated that we already have as a team. So we use this matching system to sort of find what is similar between what ChatGPT has made and what we already have. This tells us how good our model is at finding the test cases that we missed, okay? So ideally, the team always wants us to find better ways to teach our model to think outside what they have. So from here, we usually request our teammates at the QA team to fill in a survey, which is available through the Google form. This survey helps us understand. This survey form helps us understand. Let me increase the size. This survey form helps us quantify what did the model get right. So we tell them to tell us, do you already have this in your test plan? If you say yes, well and good. If you, or is it already there? Is it invalid? Or is there another reason you've denied it? So later, next year, we will be publishing a paper about this tool we have developed. It will be, I think, presented in MSR, Mining Software Repositories. And our great friends, all of us who are working on this tool, are actually open to anyone who wants to maybe take part in it and learn how to maybe prompt models like ChatGPT, okay? So, with that, let's return to our presentation. We have seen the case studies. I've talked about Bug and how it helps us predict and track bugs in Mozilla products. It has really streamlined the development process. It has enabled efficiency through wonderful bug identification and resolution. Then I've just shown you Test Sage. That's the name of our tool that we use to automate test cases. And we are trying to analyze what has been the impact of such tools that Mozilla and other development teams. So it has helped us accelerate development time. We usually now ship products. Imagine we developed this tool in June, and we are going to ship 10 new features this month, okay? Imagine 10 new browser features. I can't mention them there yet because they are not yet released, so it will be breaking the NDA. And we have seen improved test coverage. 25% of the test cases developed by our model are actually new, and the teams missed it. So nowadays, engineers only focus on creativity and high-level decision-making. They do not need to think, maybe we have missed something, okay? Then now it has been able for these teams to scale and increase software dimensionality. Even now we can see that as software gets complex, we really need the power of machine learning to automate some of these processes. Or Copilot. Copilot actually made a survey and they found out that people using Copilot complete tasks 55% faster. I'm not sponsored by Copilot, by the way, but I'm just mentioning that it's a tool that could aid your prospects as a software engineer. What's the hope for the future? Well, one is machine learning for software engineering is very dependent on Python, and the advancement of the language is key in how fast this other field can progress. Will we get increased automation? I hope so. We would want to see immediately we are developing, we're already finding test cases in maybe a minute or two. Also, another question is how will we be able to create or to adopt machine learning in systems that self-adapt? We have systems that keep changing day in, day out. Can machine learning models self-adapt to how the environments keep changing? That's something we hope for in the future. And I believe personally that artificial intelligence won't take our jobs. It will maybe take jobs for the person who doesn't know how to use it. Then also, we look at that actually means that the value of developers will increase with time. And this just means that in order for us to reach the goal where we see the field, we together as a community have to come around and build certain tools that help software engineers, okay? So, with that, this would conclude the key part of my talk. And right now, we'll enter a phase where we'll just have some toned down bits, talk about AI and machine learning and some tools, okay? This is a quote for most of you who maybe would want to get into it or who are lazy to maybe start the field. If you do not start learning how to use AI, I think you'll be a dinosaur in 3 years. Because we believe this is a field that is changing everything, medicine, healthcare, software engineering, even automation. Everything now depends on AI. And together with actually some friends at Mozilla, we came up with a list of resources, libraries, tools, and skills that you could use to learn machine learning. You can scan that QR code. That QR code contains, one, a list of resources from DeepMind. These are courses and libraries that they request any AI engineer to learn. It also has a follow-up of my talk today. A small podcast where I got two AIs to speak to each other about machine learning for software engineering. Then it has a possible learning path. A learning path means you ask yourself, what should you do as a beginner? What should you do in the intermediate stage? Or what should you do when you're in an advanced stage? That is a link to my blog where I write about all that and I show a list of the resources, okay? Is anyone who, are you still taking the picture? Okay. So, this is a career tip also we have for those who want to join the ML fields. Hands-on project is the way to mastering machine learning. Hands-on projects show how much skill you have and show how well you can implement solutions. And as our first keynote speaker was saying, open source is ideally one of the places that hold machine learning. Open source will solidify your experience, and I'm going to share a small journey of someone who I know personally. That person was called Aaron. Aaron was someone who studied, I think, BCM in high school. He studied BCM, I think, at St. Mary's. So in his first year, in his S6, he realized he doesn't want to become a doctor, and he wants to advance into tech. So Aaron switched up from doing BCM to studying computer science at UCU. So from there, Aaron, after graduating, like every single one of us, struggles to find a job, right? Like so many graduates every time these days keep like sitting on the line or they're hoping for a job. And especially for someone, most of the interviews, they used to ask him, why did you switch up from being a doctor to a computer scientist? That answer alone, he used to find it hard for people to understand because maybe they just thought he's a newbie or he was a wannabe trying to latch onto tech. So Aaron, after graduating, tries numerous interviews and fails. But then Aaron meets one person who tells him it is time for him to learn open source. So Aaron was introduced to open source where I think he told me his first contribution was contributing to scikit-learn. Scikit-learn is the machine learning library that most beginners, I think, start with. So Aaron made his first contribution, which was just a simple change to the documentation. He got the documentation on the scikit-learn website. He just changed a few of the sentences. That was his first contribution. Then from there, he kept on searching through the code bases and he found a specific function. Imagine in one code base, you just pick one function and that is all you know, but that function is applied in every machine learning model in scikit-learn. That was the get feature names out function. If you use scikit-learn, you use that function to get the feature names out. So every issue he used to see related to that function, Aaron kept contributing. And over the time, he found himself learning about the rest of the functions that depend on the get feature names out function. From there, he even went to other open source projects to find out where do they have issues with the get feature names out function, in Bug. He also came, I remember we chatted about how he started solving errors from scikit-learn within Bug. So from his introduction to open source, Aaron managed to gain some pretty solid experience. He even managed to secure an internship with Outreachy and a very, very unique internship with scikit-learn through the, what is it called? I'm forgetting the internship program that they have. It's called, it's funded by the Chan Zuckerberg Initiative. He managed to win a sponsorship. He was sponsored by the Chan Zuckerberg Foundation to work under scikit-learn. But before that, his experience contributing to scikit-learn helped him get into Outreachy. And then from Outreachy, he was seen as a possible candidate to maybe join the scikit-learn team. He did that remotely. And from there on at scikit-learn, he met a professor, or scikit-learn has an extremely well distributed team around the world. From there, he met a professor who saw his skills on open source and decided to take him up as his student under full scholarship in the United States. So from someone who just had a mere motivation just to make a few lines of code, he ended up meeting someone he has never met face to face who gave him a full scholarship in the United States. So Aaron right now is studying and studying an MSc in AI and machine learning, and he's on a full scholarship from just a leap of faith. You imagine it just took maybe about 4 years from when he graduated, from when he left A-level to when he received that great news. So my summary of this is that I do believe open source has open opportunities, and if you ever want to try, please feel free. We can have a chat about many of the libraries that you could use to elevate your career. So these are our tips for success, and as a Ugandan, because I do believe we have different problems than the other guys, right? Yeah. So the first one which I would have started is try and get into many remote internships, paid or unpaid, okay? This will help you build your CV with personal projects. The second one I would say is attend as many conferences here now. Someone who has never known Outreachy will now go and try and get into Outreachy. I would encourage this, though there's a bias lately. Such programs like Outreachy, MLH, there is a tendency for women getting in easier than men, right? So they are trying to lean a bit on the side of women. So girls, please go ahead. We need more of you in tech. Never stop learning, and open source for growth. So this concludes my presentation. I hope at least you have got some inspiration, right? So I will take. How many people have questions?
Yeah, let's. Yeah.
1, 2, 3.
Okay, yeah,
3. Okay, 3 is the perfect number.
Thank you so much, Ron.
Yes.
I think what you've shared is really commendable and
Yeah.
about open source.
Yeah.
I just do have a question, one from my past experience with open source. In the past, I've actually contributed to Node.js, Unicd, what everyone uses to run fetch API in JavaScript.
Mm.
But then, having gotten the, usually when someone's starting out open source in a very big project like you have with Mozilla, I feel like oftentimes it's abstract. You're going to look at the code base and feel scared. You're not going to figure out what to do. What was your approach towards that?
Okay.
The second question is about test bug. You called it test stage.
Test stage.
Yeah, I just wanted to understand what's its scope. I understand and agree with everyone doing open source. Tests is something you can't miss for any feature. So recently I do work on a couple of things. Basically building open source tools for Firebase and stuff like that. So I just wanted to understand, because in the workflow, a lot of time you actually use less time building the actual feature and so much more time building the test cases and all that stuff. So I saw test stage basically just builds out the test case, not the actual test on the product or the feature. So I just wanted to understand, is that something you're considering? Because I feel like it could do more than just a test case.
Yeah.
What if I could get a whole test out there? Yeah, so those are my
great.
two questions.
Okay,
But
great.
really inspiring about everything you've done. Thank you.
Let me first answer this question before I forget. So the first question was, how do you start out from large code bases, right? I gave an example of the story of Aaron. Remember, Aaron just picked one function in the whole scikit-learn code base. That was the get feature names out function. So what Aaron would do, if there was any issue related to get feature names out, because he understood how the function works and where it's applied in each model, he just kept picking out issues related to get feature names out, not only from scikit-learn, but even from other open source libraries. So what even the teams at Mozilla tell someone is pick a class or pick a Python file. I'm sure most, or you can scan through the issues. You see maybe the first contribution is contribute basically to documentation. That's the first one. Then the second one is pick a small function or a class and just look at where the issues are coming from within that class. And from then on, I feel like step by step, you will be able to, we all think that maybe the contributions we're supposed to make have to be to a whole issue at large, or maybe to the whole problem or the issue that you find on GitHub. But most of the beginners, maybe the outreachy interns, what they do is they start with a small issue, like maybe there is, let me give you, my first contribution to scikit-learn was related to, we were renaming, refactoring a certain class and its applications to the code base. So there was this classifier that had to be renamed all throughout the code base. So as we went on through every time it was mentioned, we as a team, we were 3 people, we tried to understand if we rename it, how does it affect other parts? So we went from finding out where the renaming comes from, even we've got to understand how the other parts can be, or how the other parts work. So it's usually, in short, to summarize, start with a function or a class, look at it, any errors to it. If not, you wait. Some other time, maybe you'll find another issue that's related to a certain function or class. So it starts small, really really tiny. A few lines of code, and that's it. Second question was test stage. How can we improve test stage? Yes, we're actually trying to improve test stage. This is the initial rollout of test stage. It just creates test cases because Mozilla hires external testers, right? We get a group of people and we tell them, we give them those list of test cases, verify that the tab button works. So we want you to go, we give you a series of steps, go and check if you click plus, does it open a new tab? Well and good. For the developers on the other side, we want to develop for them, we want to teach test stage about the code base that we have so that it can implement ways of even automatically solving bugs or automatically creating tests. Okay? But in professional software development, there's sort of an arc with trusting AI to develop tests, right? It's usually so hard to, you maybe try, but you'll find a bug in another bug. Imagine a problem in a test case. So you don't know what is right. So there's still more research that's needed. And for your case, I would maybe say, if make the code, try to develop tests as small tests as possible. Not maybe for a whole class and whole module, right? Small as possible. But I could give you access to test stage if you want, and you see if it can help your test case, because it's trained on numerous previous code and test cases from Mozilla. Okay, it's not limited right now, but there are some other aspects we have not yet communicated, which I may not be able to discuss. But maybe you can just sign an NDA and you just are in. Okay. Yeah. Next question.
All right, Mr. John, thanks for the presentation. Yeah, it's amazing what you're working on, especially currently in the good run to make intelligent developer toolings. So my question is, do you have any plans of test stage actually generating the test code? Yeah, maybe following some linters that are known and all that. You plan for it to actually, after it has generated the test cases, to also write the test code, because I think no one wants to write that again if possible. Then I think this is cool, and you can also look into having a feedback system where you can actually now track the bugs when they happen, so that you know which bugs happened and we are not caught up in the other stage. Yeah, I don't know where I can find more information about it. It's interesting. Thank you. But do you plan like any time for it to actually generate the code? Yeah, thank you.
Okay. Okay. I remember last weekend we had a meeting. We want to increase the capabilities of test stage. The QA team said test stage well gets the missed test cases, but again, we want it to think more, to be different. So if we are to shift from just test cases to code, we sort of need to now work with the developers. That is, I think, in the pipeline. It will come in a second paper, maybe after we present at MSR. And we do believe test stage can also generate code. As I told him, it's in the plan. But then we already have certain stop signs. There is another tool our friend is building from an intern from the University of Toronto. This one is a code review tool. So when, let me say, code has been submitted to the code base, we have an AI that can offer inline code suggestions. Maybe you missed this, maybe there's a possible bug, or maybe there is an issue with the way you've implemented this test case. So in short, yes, the answer is yes. We'll be able to create a way for test stage to generate code, but it involves a lot of checking, and we will start as small as possible. Maybe with the smallest first 3 lines of code, first 5 lines, but then we will need your help, you, our open source community. Because we work on this tool, 5 people, you imagine. But there are teams of 10 features that depend on it, okay? And yeah, there's someone else? Okay, that is it? Yeah. Okay, thank you so much. And if you wanted to contact me, you saw my LinkedIn, huh?
You can show it again.
Okay, please. That is my LinkedIn at the bottom. Okay? We can talk about machine learning for software engineering. That's my LinkedIn at the bottom. We can talk about machine learning for software engineering. Even when